Hi Coach L, this is tutorial 3, reading a potentiometer.
This is the code for experiment 3, reading a potentiometer. In this experiment, we're going to measure the position of the potentiometer and use it to control the blink rate of the LED. First, we're going to create variables that control which pin, which area the LED in the potentiometer is connected to. This line of code here, sensor pin 0, shows that the potentiometer is connected to the 0 pin, which is A0, which converts the analog to digital, which needs to be done for the potentiometer. This defines that LED pin 13 is going to be the pin number that the LED is connected to. In void setup, we go to pin mode, LED pin output, and that's going to set LED pin 13 as an output, meaning the power is going to go to pin 13 and light up the LED. We go to void loop here, and again we're going to define a variable that is going to be called sensor value, and it's going to be defined as taking the information from sensor pin, which is the potentiometer is connected to, using the analog read function to read the sensor pin, and that's going to be the sensor value. Then digital rate LED pin high is going to turn the LED on, and then delay sensor value is going to delay the value for the value of the sensor value. So depending on what the position the potentiometer is at, it will increase or decrease the rate of blinking of the LED. Then digital rate LED pin low is going to turn the LED off here. And again, we're going to delay for the sensor value. So delay for the value of the sensor value, and then loop back to the top. Okay, so this white wire, connects from pin 13, right over here, through the 100 ohm resistor into the anode of the LED. And then this black wire connects the cathode into the ground ports right here to ground the LED. And then this this red wire here connects these ports from the this power strip into the 3.34 volt pin. Okay, and that makes it so, and then this black wire connects these grounds to a ground pin right here, so making this wire grounded for the LED. And then we move over to the pot. This white wire provides power to the pot by plugging into the pin, the power strip, which is connected by the red wire to pin 3.3 volts. Then this yellow wire connects the pot to pin 4.0, which translates the analog to digital. And then this black wire grounds the pot by plugging into the grounding pins, which is then connected to this ground over here. Now we see the LED blinking, and by using our screwdriver, we can change the rate of the blink by adjusting the potentiometer. So right now it's all the way over to the 1 on the potentiometer right here, making it the slowest blinking. And as we move it all the way to 3, then the blinking gets faster. And then when we get all the way over here, it blinks very fast. And there we can barely see it blinking, but if we go back over, then you can see it blinking. And there we go, all done. This is the code for potentiometer modified. Here, I define a new variable, sensor pin 2, and initialize it to have a value of 1, which is the analog input for the second potentiometer that I added on the board. Here, I defined LED pin 2 as a new variable that is going to be the pin number that the second LED is connected to. So 12 is the pin that the LED is connected to. Over here, pin mode LED pin 2 output. I am setting LED pin 2 as an output, meaning the power will go from that pin into the second LED. Under void loop, I have the code for the first LED and potentiometer, and then I define a local variable that will be used inside void loop called for sensor value 2, and it will use the analog read function to read sensor pin 2 and store it as the sensor value 2. So I'll take the information from the second potentiometer and read it and use it to determine the speed that the second LED will be blinking at. Here, digital array LED pin 2 high will turn the LED on. Delay sensor value 2 will delay the LED for the value of the sensor value 2 for potentiometer 2. Here, digital write LED pin 2 low will turn the LED off, and then delay sensor value 2 will again delay the value for the value from sensor value 2. And then that's it. Again, the same wiring for the red LED is from the basic video, part of the video. So the white wire is connecting to pin 13 through the 100 ohm resistor to the red LED, and then the black wire for the red LED is grounding it. And for the yellow LED, the orange wire is connects the power from pin 12 right here, through the 100 ohm resistor right here into the anode of the yellow LED. Then the short black wire grounds the cathode of the LED into the ground bar that is grounded by this black wire into a ground pin over here. And then we move down to the potentiometers. Potentiometer 1 controls the red LED. Potentiometer 2 controls the yellow LED. Same wiring for the potentiometer 1 as before. Potentiometer 2, the green wire connects the potentiometer to the power strip here, which is connected by the red wire to 3.3 volts. The yellow wire here connects the potentiometer to the analog reader. So it takes the sensor value from this potentiometer to A1, pin A1, which converts it from analog to digital. And then this black wire here grounds the potentiometer by using the same ground column and grounding it through this black wire into this ground pin over here. And then you can see it working by this potentiometer changing the red one. So as you go this way, it goes faster. See that? And then if we move the potentiometer 2, the yellow LED will move faster. There, and we can move this one back, and yellow will still stay fast. All done.